Hey everyone, welcome to the weekly space hangout for Friday, March 4th. Season 4 of House of Cards starts today. 2016. Joining us, we actually got a bunch of stories this week. We're going to be talking about Scott Kelly coming back from space, fast radio bursts, a new supersonic jet, ancient history on Mars. I should move this over here so it looks like I'm like just looking right into the camera as I do it. Searching for icebound life on Earth. The temperatures and weather on Titan, the best time to go surfing, an international village on the moon, going back to Venus, and more. So we got a ton of stories, and we got a ton of people here today. So we're gonna go really fast. So, but joining us this week, we've got Carolyn Collins Petersen.
Hi.
Hey, Carolyn, aka
Hi.
the Space Writer. We've got Jolene Creighton, I think. I can't tell because you don't have a lower third. But
I
that's
know, no one knows. I'm a mythical being. I don't know where I come from.
But
here I am.
But your video looks great, very stable. Your audio is good. We've solved that.
You win some, you
problem.
lose some.
Yeah, no, I think we can solve the
yeah.
lower third problem. Even just like have you hold up a little sign will work.
Yeah.
We got Kimberly Cartier. Hey, Kimberly.
Hey, Fraser. Hello, viewers.
We got Morgan Rehnberg. Hey, Morgan.
Hi, everyone.
And we got Dr. Nicole Gugliucci. Hey, Nicole. And
my dog is grumbling.
And so, what's the dog's name?
Macy.
Macy. Oh. Aww, this is awesome. Oh, that could be dangerous. And our very special guest from NASA, Dr. Michelle Thaller. Welcome to the Weekly Space Hangout.
Great to be here. I'm a big fan of all of you guys. Yay!
Yay! I think this is like the first time that we've actually crossed all the streams, which is great, and we're so glad to.
Don't cross the streams.
No, well, we saw the new Ghostbusters trailer, so I'm ready to think in Ghostbusterisms again. Right, Nicole, are you squeeing out there a little bit?
A little bit.
Okay.
I'm very excited for that movie.
All right, so Michelle, welcome again to the Weekly Space Hangout. And for people who don't know who you are and haven't watched a whole bunch of television and listened to a bunch of podcasts and are watching NASA's newsfeed all the time, who are you and what do you do?
Hey, well, I'm an astronomer. At least I used to be. I kind of got into science management and communication about 15 years ago. And now I'm at NASA headquarters. I spent about 13 years at JPL, Jet Propulsion Laboratory, about 6 years at Goddard Space Flight Center as their assistant director of science. And now I'm the deputy director for science communication at NASA headquarters. So that's a lot of fun. But I'm originally an astrophysicist, so that's my real specialty.
What was your sort of original research in?
So it was binary stars, and specifically these really, really massive binary stars that sometimes orbit each other once every couple of days. And there are these huge shock waves that the atmospheres produce between these giant, it's all out of control. And those shock waves actually generate a lot of interesting chemistry, that they change the way the stars evolve. So the whole story about how stars live and die, and these really, really massive ones that go supernova, that was sort of my specialty.
Awesome. Like the Type 1As, or?
Well, not so much that. So in that case, you have a white dwarf, and you have a massive star dumping matter onto it. That's when you get the Type 1 supernovae. So in most cases, the stars I studied, both the individual stars were big enough to supernova all by themselves. So you'd have like two stars that were each 20 times the mass of the sun or 30 times the mass of the sun. So two big guys both orbiting around each other.
Right. Okay. But now, as you said, your work is a lot more general now that you're working for the communications team originally at JPL. Now, more NASA in general. So let's talk about some of the really interesting news that's coming out of NASA that's kind of crossed your office just in the last couple of weeks. What are some stories that you're really excited about?
Yeah, that's the fun thing. It's sort of like being a kid in a candy store. So I mean, we're continuing to get amazing things in from Pluto. And I know it was just a couple days ago that they, I think it was yesterday actually, they had a beautiful picture of methane snow actually on the mountain tops of Pluto. Some of those mountain tops are well over 10,000 feet high, and those are mountains of pure water ice, which is just incredible. And I hope everybody's seen these gorgeous pictures of these flowing glaciers, and the glaciers are made out of methane and nitrogen ice. So I mean that continues to be the gift that keeps giving. I mean we're still getting the data in from New Horizons. But then, there's been so much other great stuff. I mean, of course, the gravity wave thing was huge. The gravity wave, the LIGO, just be very clear. I mean, LIGO is funded by the National Science Foundation, but NASA, we've got a big interest in gravity waves too, and we have a mission that we're hoping to launch called LISA, the Laser Interferometric Space Antenna, which will be basically a huge version of LIGO, where LIGO has a baseline. The lasers are about 2 miles long. We're going to go for like 3 million miles, so we'll be able to see much smaller gravity waves. So that was a really big deal. There's some really great missions coming up this summer that we're getting ready for. We arrive at Jupiter. We haven't had a dedicated spacecraft at Jupiter for a long time, and the Juno spacecraft arrives July 4th. So I mean, hopefully there'll be sort of spectacular fireworks that day, or at least not everything goes well for Juno. But Juno's going into a polar orbit around Jupiter, which means it'll map the whole thing as Jupiter turns underneath it. And it's going to be closer to Jupiter than anything ever has before, as far as a spacecraft. And the cool thing about that is, I mean, it's an extremely dangerous radiation environment. Jupiter has this kick-ass magnetic field, which is, I think, 20,000 times stronger than the Earth's magnetic field. And so it's sort of like existing inside a particle accelerator. And given all that radiation environment, I mean, we're hoping, if all goes well, Juno will last about 2 years. But we're going to be mapping the auroras of Jupiter. We're going to be looking at the cloud tops and the weather patterns and all of that. And the cool thing is, there's a camera called JunoCam on the spacecraft, which the public can actually help us decide what to look at. It's a citizen science project. So, coming, I think round about November is when we're going to start that up. November of this coming year. You can actually have some say in what part of Jupiter we look at and what sort of data we take. And there's more.
There's more. Well, absolutely. Feel free to talk about more. But one of the things that I've been saying almost since I've been doing, I started Universe Today 15 years ago, 16 years ago, and I've been saying that we're in the golden age of astronomy. That, that there are more missions now, more observatories in more places, more nooks and crannies of the whole solar system, sending back more and more data. How for the time that you've been, how has that sort of changed, your perspective of what you've known about the universe?
It just kind of freaks me out, the sort of wonderful resources we have. I mean, I'm thinking about Cassini, right? So, I mean, Cassini has been around Saturn now for a little more than 10 years, and it will be ending its mission later this year. And we've had this kick-ass, huge, dynamic observatory around Saturn, just routinely returning these pictures of Saturn's moons, of the rings, of the beautiful planet, and I've kind of gotten used to it. And, I mean, yes, it's the golden age of specifically planetary, but also astronomy. I am so going to miss having an observatory around Saturn. So, I mean, Cassini's done an incredible job. That's one that is going to be just, sort of bittersweet this year as we actually dive it into Saturn deliberately. And we should get some incredible pictures when that happens. But you really can't minimize just how important some of these things are, like Pluto. I mean, Pluto now is a place. And last summer, let's say last spring, a year ago, we'd never seen that place. We'd never seen the mountains, the glaciers. It was just basically a couple pixels that the Hubble Space Telescope had taken a picture of. And now it's a world. And the joy in that, right? I mean, everybody's job has a lot of stuff you don't want to deal with, and there's budgets and there's red tape. But, 10% of my job is, my God, we've seen a new world, and it's been a wonderful year for that.
Yeah, you sort of like, once you get those close-up pictures, but it's a flyby, you can't wait for that orbiter to get developed and get sent, and that lander and the rover. Like, there's this additional levels of science. You get these tantalizing hints of what's there. I mean, when you think about researchers they've had what they've had with Europa since the Voyagers were there, since Galileo got there, a little bit of hints with the New Horizons mission, but they've had to keep looking at those same pictures for years and years and years, and now finally we're going to get some new pictures and some new observations with Juno, and then, but more importantly, things like the new Europa mission. So, how do you guys manage that sort of? I don't know. I would be so impatient all the time.
We don't manage it. I mean, we're just kind of tearing our hair out, because I mean, if I had my way, we would have a Cassini-class instrument at every single planet, maybe every single major moon. So, I mean, you've got moons like Titan and moons like Ganymede, the places that we should have large-scale presence all the time. And you know, I mean, I'm sorry. I mean, my opinion is it's some of the best money the federal government spends, right? I mean, we operate over 100 active science missions at NASA, and our science budget is on the order of $5 billion a year. The total NASA budget's about $19 to $20 billion, but the science budget, all of those planetary probes, the Mars rovers, the Hubble Space Telescope, all that's about $5 billion a year. And the knowledge return and the technology return is so tremendous. I mean, think about Juno. Juno's the first spacecraft to actually use solar panels in the outer solar system. So instead of using a plutonium battery, it's entirely solar powered. So we had to make the most efficient, high gain solar panels ever made for Juno. And I think that's going to turn, you know, that's going to drive the solar industry back in the United States and really set us up well to kind of lead that industry. So, I mean, it's a tremendously good investment, but I mean, I just love the cool stuff that comes out of it. Like you said, the continual learning. I mean, think about, you know, with Juno, we're going to be looking at the auroras of Jupiter, the poles of Jupiter, and that was how we discovered the largest ocean in the solar system. You know, I mean, right now Earth is in 4th place for the amount of liquid water, and the first place is Ganymede, the moon of Jupiter, and we discovered that ocean by looking at the auroras of Ganymede. I mean, that's mind-blowing.
Yeah. So, you know, as of a couple of weeks ago, gravitational waves was one of these mysteries that, you know, although they've been seen indirectly thanks to the pulsar observations back in the 70s, they had never been detected directly, and there had been a lot of, you know, effort put in to actually turn up this direct detection of gravitational waves. But now it's like we were there when this discovery was made, when this theorized thing was confirmed. So what are some sort of stuff that's just outside our realm of knowledge now that you think we might get some answers to in the next, you know, in the next 5, 10, you know, 20 years we'll get some answers to?
Well, I mean, there's some real big ones. I mean, staying with the planetary theme, I don't think we're all that far away from discovering evidence of life, right? So, I mean, I think that one of these icy moons, or Mars, you know, Titan, Europa, Enceladus, you know, we're going to have some detection. It'll probably be very indirect. It'll probably be like a molecule where we'll say, okay, there's no way we could make this molecule without life. And that's not as exciting as having a little creature. But, I mean, I think that we're going to see that sea change in the next decade where we know there's life somewhere else. But then as far as the bigger questions of the universe, we've got WFIRST coming up. And WFIRST is the Wide Field Infrared Space Telescope. It's a Hubble-class instrument. It's actually the same observatory as Hubble. Hubble was a certain species of spy satellite, and this is another one that we actually got from the Defense Department. And we're probably going to at least start to track down what dark energy is. So, you know, in 2000, I guess the Nobel Prize was 2011, I'm trying to remember, for dark energy. But at any rate, you know, the idea that the universe is not only expanding, but it's accelerating, which is something nobody ordered. I mean, we had no idea that was the case. I think WFIRST will do these really, really large surveys of all the galaxies, and we'll be able to see how dark energy is working and how it's changed over time. Because right now it looks like, in fact, the universe was actually slowing down for a while. It was expanding but slowing down until round about 5 billion years ago, where something changed, and then everything just took off. So we've got to figure out what happened there. And then the other one is dark matter. So, I mean, with a number of our different telescopes, you know, I mean, Hubble is very good at finding where dark matter is now by looking at the gravitational lensing that dark matter creates. But with CERN, you know, with the particle accelerators, you know, here on Earth, and then with some of the stuff we're launching in space, like the Fermi and Swift missions, are very high-energy X-ray and gamma-ray satellites, may have detected evidence of dark matter annihilating, actually sort of hitting itself and annihilating. So all of that is very tentative still. But so in the next 10 years, I'm looking for life. I'm looking for, you know, is there really dark energy, and what's going on with the expansion, and what the heck is dark matter? I mean, think about what a change that'll be in 10 years.
One of the big new tools that's sort of we're just around the corner from is the James Webb Space Telescope, and this is hopefully going to fly in the next couple of years. Yep. So what can people expect to come out of James Webb?
Well, you know, it's funny. I was actually just at the James Webb control room, the new brand new control room. I had the new furniture smell yesterday. That was at the Hubble Space Telescope Institute, and that really kind of frightened me because it meant this was really real. I mean, when you work on a project, and you know, to actually see people ready to be working this and actually running the telescope, I was like, okay, you know, we got to get this done. It's a tremendous telescope. The mirror is 7 times the size of the Hubble Space Telescope, and I mean, some of the things you're going to expect out of it. I mean, one of the things I think is going to be mind-blowing is we hope to be able to detect what the atmospheres of exoplanets really are like. So some of these planets around stars that are light years away, we should be able to tell whether they have things like water vapor or methane or oxygen. And that'll be a lot of soul searching on our part, because you can't necessarily say that there's definitely life there if there's oxygen and water. We're working on all kinds of models of what planetary atmospheres could be like, because how do you interpret this? How do you understand that? But I think that, you know, in the next 10 years, I'm going to be able to point at a star and say that star's planet, it has a rich oxygen water vapor atmosphere. You know, you can look at a star in a telescope and actually say there's a good chance that there's life there. But that's going to be tantalizing. I'm not sure we're going to actually have a life marker, but we will know a lot more about exoplanets. But, you know, in the cosmology stuff, the really large-scale stuff, JWST has so much sensitivity and collecting power that it should be able to see so far away that the light coming from, you know, it's just coming from about 13 billion years ago. And that was about when we think the very first stars formed. So, I mean, this sounds kind of romantic, but it's actually true that we actually hope to observe the first stars turn on ever, and then watch the whole thing unfold as we look back into the universe. I mean, that's pretty profound.
Yeah, I mean, there's still a lot of mysteries even about how big those first stars could get. I mean,
right?
were they constrained by the kinds of limits that we have today, or, you know, I've seen supercomputer simulations looking at, like, what if they had 60,000 times the mass of the sun? Like, what happens when you get that much hydrogen into a close area and then have it try to turn into a star? What do you get? And we don't even know.
I mean, think about this. So, I mean, we know that there are these supermassive black holes in the middles of galaxies, and some of these are billions of times the mass of the sun. And you just think, how the heck do you get that, right? How do you get a black hole that is billions of times the mass of the sun? Does a galaxy form around that? Or do stars in a young galaxy start to die, and then they all coalesce into the middle to form a big black hole? We don't really know the chicken and the egg question yet as to really how those big black holes influence galaxies. And so the giant stars you're talking about, and, you know, I couldn't say whether they were 10,000 times the mass of the sun or maybe a couple hundred times the mass of the sun, but I mean, these are a real holy grail, because the universe is made out of all kinds of chemistry besides hydrogen and helium. You know, famously, the Big Bang only made hydrogen and helium. And when you look at very, very distant cosmological light, like the cosmic microwave background, so the cosmic microwave background came from about 300,000 years after the Big Bang. And at that point, you've just got hydrogen and helium, like all at the same temperature. And somehow, in basically the next 500 million years, 500 million years, all of the chemistry changes. And we think that was all done through these supernovae, through these giant stars exploding. But the change was so fast. You know, I mean, yes, there's definitely more and more chemical elements over time in the universe, but the majority of change took place only in the first 500 million years. So, I mean, there was a party at the beginning of the universe, right? There was something really, really dramatic going on when those first stars kicked off.
So, you know, I think, you know, perhaps when you started your career, you know, when I think back to, like, the times of Carl Sagan, you know, science advocacy and getting out there and publicizing the work that NASA's doing, the science, was seen in a poor light by the scientists. It feels like something that they didn't need to do, that wasn't that valuable to the public. And yet over the last, you know, 20, 25 years, we've really seen, you know, scientists embrace it. I mean, most of the panelists on this show are working scientists. You know, have really kind of embraced this outreach and the public. And, you know, here we are. We've got, you know, hundreds of people watching right now who are so enthusiastic about space and they want to learn about what's going on. I'd love to sort of hear your perspective on as a communications person, whose person it is really to communicate this science and space out there. How has connecting with the public sort of changed in your experience?
Well, one of the things that I really see is a huge generational difference. I think that, you know, people that are, you know, sort of on the, you know, 40s and under have really embraced social media in their lives. And this idea that you're in constant communication about what you're doing, you know, and how it relates to other people, I think that's been a complete culture shift in the way people are scientists. I mean, we just communicate now as a matter of course. Nobody really thinks anymore about spending a day just by themselves, you know, just reading a book and not communicating. I mean, it's always fun to get off the grid and go camping or something, but I'm constantly communicating. I'm constantly on Facebook or Twitter or Tumblr or anything. And I think that that has completely shifted what people think the job of a scientist is. I mean, in a generation ago, you still really weren't much of a scientist unless you published your results. You could make your results, you could do your discoveries, but nothing mattered if you never published it, and none of the other scientists ever knew about it. So communication was always the last step of science. Otherwise, you wouldn't get grant money, otherwise you wouldn't get tenure at university. You needed to actually show that you were publishing your results. And now, while people are still publishing in professional journals, there's this big culture shift to letting everybody know publicly what's going on. I mean, this is public money. When you work for NASA, you're using people's tax money to support your science. And so there is this wonderful sense of obligation that you really should be getting people involved that are funding this. And I think as scientists, we all want to live in a culture where science is appreciated and people are culturally literate. So I have to say, being a communication scientist, I think there still is sometimes in the professional circles a little bit of a sense that you're not a real scientist if you concentrate on communication. But I see a huge shift in the way young people interpret that. I think scientists under 40 really know that they have to be constantly communicating what they're doing.
Yeah, and not just to the public, but just that level of communication brings on collaborators. It brings other people's work to your attention. NASA. I always sort of give mad props to NASA now as being literally the best social media communications out there. I originally started what I was doing because I felt there was a real lack of that level of communication, and now, I can't compete with an astronaut taking pictures from space, and then sharing them out on Instagram. It's magic. So, is that a big level, I guess, of the thinking now of NASA? I mean, a lot of energy is put in just to make sure that those people who really are paying for the people to be up in space are getting to appreciate the rewards that come from it as well.
Absolutely. I mean, the subject matter so lends itself to social media. I mean, every day there's a new image to tweet. Every day there's a new discovery. There's so much coming out. We very much are aware of the fact that the classic press release system just broke down. That people tend not to come to a big NASA press release anymore. Instead, they're checking our social media feeds. And like you said, the subject matter, astronauts being on the space station, all of these 100 missions, they all have social media people. They're all trying to get involved in this. So, I mean, social media was the best thing that ever happened to NASA, I think.
Yeah, absolutely. So I'm going to throw a bunch of questions from the audience at you. Let's see. Okay, so Galaxia asks, back to your exoplanets concept, what other sources could there be to cause the combination of oxygen and methane in an exoplanet's atmosphere? You don't want to be sure, but what else could it be but life?
Well, this is actually what we're modeling right now. That's a great question. So, methane and water vapor and oxygen can all be produced by volcanic activity and geologic activity. But the question is, in what sort of quantities? Because oxygen famously doesn't stick around very long. It combines with everything. It dissolves into the ocean. It dissolves into rocks. It burns. So, one of the questions is, how much oxygen can you have if it's not continuously being replenished? And the sad thing is that we don't really know the answer to that. And this is what's going to be frustrating about those first results, is we may see a very strong oxygen signal, and we just cannot say for sure. I mean, was there a recent burst of volcanic activity on that planet that we're picking up? So, that's the stuff. I mean, the volcanoes are very good producers of a lot of these gases. And some people have even modeled desert planets as having oxygen-rich atmospheres. I'm not a specialist in that, so I couldn't tell you why. But one thing I'll say is that there's a whole subject now, a whole category of scientists that are trying to understand the environments of different exoplanets. Actually, at Goddard, one of the things we're working on is how different orbits would affect the atmospheres of planets. A lot of the exoplanets we see are very close to their stars. I mean, they might be very dim stars, what they call M-dwarf stars, so you could actually snuggle up right next to the star and still have a temperature about the same temperature as the Earth. But you'd probably be tidally locked. You'd probably have one side of the planet always facing the same side of the star, sort of like the Earth and the Moon are tidally locked. So one question we're trying to model right now is, how does the atmosphere behave if that's true? Do you get a hot part of the atmosphere and a cold part, or does it circulate very well? In the case of Venus, Venus actually orbits, I should say, it orbits the sun, but it actually turns on its axis very, very slowly. And still the atmosphere goes faster than the rate that Venus turns at. So Venus might be an example of how you would actually have a consistent temperature, even if you weren't spinning very quickly on the orbital axis. So there's all types of questions about that. But yeah, the big one is the minerals and the geology of the planet and how that might affect the gas content.
So I got another question. This one comes from Joel Ruppenthal. Will James Webb be able to find Planet 9?
Well, see, a particularly good backyard telescope would be able to find Planet 9 if you knew where to look. This is the problem. Planet 9, if it really is something on the order of 5 to 10 times the mass of the Earth, shouldn't be that dim. And the thing is that we have no idea where it would be in this huge orbit. So famously, I mean, Mike Brown is a really good guy, and when he came out with this, that sort of told me that this probably wasn't just nonsense. I mean, we haven't found it yet, but if Mike thought there was a good chance of this, I'd probably put my money with Mike, actually. So we know that these Kuiper Belt object orbits are aligned, but we don't know where in a 15,000-year orbit this large planet might be. So that means there's a lot of the sky to scan looking for this thing. And the Hubble Space Telescope, for example, I mean, the Hubble just takes a picture of, I think, one 10/1000th of the sky at one time. It's a very, very small frame. And so it just doesn't make sense for the Hubble Space Telescope to sort of be randomly looking for this. The frame is just too small. So some of the world's largest telescopes, like Gemini, are actually searching for Planet 9 right now. And I think they have a pretty good chance of finding it fairly quickly if it's out there. So it's not so much that it's faint. I mean, Hubble could definitely see it. So if one of these large telescopes can observe a big part of the sky and find it, then I think the next day Hubble will drop what it's doing and go see that planet. So it's not that it's so faint. It's very hard to find.
Yeah. Okay, so one last question here, and then we'll move on to the regular show because I think this is going to be a longer one. So Truck Camp and Stumpy asks, can you comment on the recent finding of the Hubble distance record? And this is, of course, the news that the most distant galaxy has been seen.
That's right. So I know it's Redshift 11. We were just talking about that, and of course Redshift 11. I don't know if I can do the math, but I mean that basically means we're seeing, I think, more than 12 billion light years away. So I mean this is something on the order of 1.5 billion years after the Big Bang. So that's the most distant galaxy right now. I believe this is part of the Frontier Fields program. I mean, this is an incredible program where Hubble actually uses microlensing, gravitational lensing, to detect very, very faint galaxies. Dark matter is so amazing. I mean, it's so mysterious. It actually makes lenses in space and time. It actually makes what we call gravitational lenses. And if a galaxy happens to line up right along the edge of one of these lenses, you can actually magnify it. It's a telescope made out of space and time, and as big as a cluster of galaxies. I mean, that's the scale of the bending of these lenses. And Hubble's learning how to use that to see very distant, faraway galaxies. I mean, that's mind-blowing. We're using a dark matter telescope, that's literally millions of light years across.
We don't know what it is, but we can use it as a telescope.
That's right.
Which is awesome. All right, so we're going to move on to the rest of the show because we do have a bunch of stories, but I know they're really all in your field of influence. So if you want to stick around and maybe comment on a few of the interesting stories that are happening. Yeah. But if people want to sort of follow you directly, where can they find you out on the social medias? Yeah,
well, I've got my Twitter handle down here, so at ML Thaller. I do a podcast for public radio called Orbital Path, so a lot of these things I talk about on that. And I've got a Facebook page. I really do try to answer as many questions as I possibly can. I will try. If it's a reasonable question, I'll try to get to you.
And then if they want to tap into the NASA feeds, where would you recommend people go?
Oh, well, I mean, so many of them. So, I mean, there's always nasa.gov. I mean, that's pretty easy. That's our main website. I particularly like our climate page, climate.nasa.gov, where you can track all of the, I think it's about 20 different satellites that are observing climate change right now. You can actually track the ocean level rise. It's a little depressing, but you can. Yeah,
the warmest month, warmest February ever.
We're toast. But there's also solarsystem.nasa.gov, which I love. That's a great page for all of the new planetary results. So yeah, to try some of that stuff. We've got lots of stuff.
That sounds wonderful. All right, well, let's move on. And I just want to warn the panelists. You put a lot of stories into the queue, and so we're going to need to go fast. So just keep that in mind as you explain the big story. Morgan, let's start with Scott Kelly returning to Earth after a year in space.
Not quite a year, but he is safely back on Earth, and they'll, over the next few weeks, be running a whole battery of tests to compare him to his brother Mark, also a former astronaut who spent the last year firmly rooted here on planet Earth. And the differences that they may or may not find between a person living in space and their identical twin living here on Earth will help us understand the effects of long-duration spaceflight on the human body, which is a key stepping stone to leaving Earth orbit and going to somewhere like, I don't know, Mars.
I saw a few things, right? He got taller. He gained about 2 inches. Weak as a kitten. So what are some of the things that have happened so far?
So the one I liked the best was he went out with his brother to try to play a game of basketball and couldn't even hit the backboard. And so you just kind of get completely out of whack in terms of we have these sort of perceptions and expectations of gravity, having lived in it every day. And then you take that away and a body adapts. And you start to think without gravity and you lose that intuitive sense of, how fast something will drop or how far you can throw it. And it doesn't take that long. It doesn't take even a year before sort of our grounding here in, eons of evolution on Earth kind of slips away from us and we become space creatures.
I was impressed just to see him walking around, though. I mean, that means he was working on it, on staying in shape.
Yeah, he had to be exercising to. I don't know if you've seen that. There's like a meme video around of an astronaut who's like keeps trying to put things and leave them, and then lets go, and then turns, and then they disappear, and they drop, and he's confused, like, where's that pen that I just put there, which I think is just wonderful. So Michelle, hopefully there's a ton of science to be extracted now from Scott. What kinds of answers do you think NASA is going to be looking for from this?
Well, we're really interested in the microbiome. I mean, you're probably familiar with the fact now that only in the last couple of years have we realized that most of our cells are not human, that, actually 9 out of 10 of your cells are actually bacteria. So not so much by mass, but by count, you are mostly bacteria. And we now think that regulates our digestive system. It may have effects on depression in our brains. And we just discovered this, and we have no idea how it responds to microgravity. So, microbiomes seem to be very correlated with DNA. Your DNA really, they call it methylization of DNA, if you actually want the technical term. So we're hoping with the twins, they have similar DNA and hopefully similar methylization too, similar microbiomes. And so that's one of the really, that's a very subtle thing that it may have a huge effect on humans, and we've just discovered it.
Wow. I think, I'm sure, this is about the limit, right? That we can't really go a lot longer than maybe a couple of years before the damage to the astronauts is really severe. So, that next step of having, we saw it in The Martian, we've seen it in 2001, that, O'Neill cylinder spinning to provide artificial gravity. Do you think that's something that we'll see in the foreseeable future?
I hope so. If that's something we have the technology for, but the thing is that that's hugely expensive. You need to build a big spacecraft. And right now we don't have the budget to do that. So that's the thing. If you really want to go to Mars, you probably want to keep people in an artificial spinning gravity environment on the way there and the way back. They're getting a lot better. Just like you were saying, that at least he got up and walked after a year in space. It used to be they had to carry them off. So they're getting better at regulating that. But things like the pressure in your eyeballs, the fluids sort of move into your head, and it's actually distorting people's eyes. So some astronauts have persistent vision problems after being in space because of that. That stuff needs to be solved.
Yeah. All right, well, let's move on. Carolyn, we're going to talk about ancient history on Mars.
Hi. Okay, so I'm kind of bummed. I'm going to start out with the fact that The Martian didn't win at the Oscars this week. But there's still plenty of Mars news. Every day I check, and it's like we have a webcam on Mars. And as with Cassini that Michelle mentioned, we have this continuing stream of images and data from the rovers and landers, and I hope that never goes away. We also get it from the MOM spacecraft from India. Well, I check this stuff every week, and today or yesterday, late last night, I got a press release from a group of French scientists who've been doing some detective work about Mars and its ancient past, and they've combined geomorphology and climate science and geophysics based on what we know of Mars today. And specifically, they've been looking at this gigantic structure on Mars called the Tharsis Dome, the Tharsis Bulge. And that got built up over millions of years from a lot of lava flows, and that's where we see Olympus Mons and several of the other volcanoes that are located on Mars. And what they've done is they've theorized that this huge buildup of lava that built the bulge somehow unbalanced the planet, and it caused a slippage in the outer layers of Mars, basically in the mantle and the crust, about 3 to 3.5 billion years ago, and that caused things to slip. Now, it didn't change the axial tilt, so the poles didn't change, but it just slipped the mantle and the crust. And the result of this is that if you take a look at the conditions back then based on the geomorphology that you get today, that you see that the Tharsis Bulge, which started out somewhere else, is now closer to the equator. You have the polar topology is now shifted a little bit, and they've been looking at the changes in river flows, river valleys that took place caused by this. There's a lot more detail to it, and I did write a story on my blog about it with a link to the actual paper. But this new geological explanation, basically the authors have suggested that this is something that planetary scientists who speculate about what early Mars was going to be like or was like, to also use this when they're searching for places where life might have formed, because there was water involved. It was a cooler, wetter Mars at that time. You had water flowing, but you also had water flowing from the fact that the volcanoes were melting the subsurface ices. And there may still be life there hidden on the rocks, or there could have at least been life in the past. So this is a sort of a tiny look using current data that we have to take a look at ancient Mars and what may have happened.
And I guess it sort of changes the search for life a little bit, because places that maybe, if the regions are changing that much, then places that you thought might have been good places to look maybe aren't good places, and places that you never would have thought to look actually could have been good candidates in the ancient past.
Well, that's true, and it's also true that you're still going to follow the water.
Right.
So they're looking at where the river valleys were and where they are.
Yeah, I know there's been some speculation in this over the last few years by looking at like coastlines and things like that. Mars itself might have changed its axial tilt over long periods of time, and the volcanism had a big impact on that, actually changing.
Well, yeah, I mean, you take this giant, massive rock and stick it on the side of a ball, and you just watch it flip. I guess I would have expected that the whole planet would have changed the tilt, but instead they're saying that there was this disconnect between the mantle and the crust and the lower layers, and that slipped around as well.
Yeah, I wonder what sort of impact that has on, the search for active volcanism on Mars today.
That's a good question. I don't know. Michelle, do you know anything about that?
I do know one of the things that I was really intrigued about is that they think they may have identified where a former pole was, that there's a huge deposit of ice that's actually under a layer of soil and dust, and that might actually be very useful for human exploration, because there's a big, big frozen chunk of water there. You've probably heard about that.
Yeah, and so you could imagine, like a piece of frozen water that used to be, as you said, at the pole, and then at some point got underground, but then moved to a different location and places you wouldn't even expect to look for sources of ice. So it's super interesting.
It's
Jolene,
also a really an intricate puzzle. It isn't just one thing. So this geomorphology and this looking at the past is just one little piece of these puzzle pieces that we're just jimmying together to figure it out.
And trying to sort of work backwards to sort of retrace the story of the geology. All right, Jolene, let's talk about Titan and the best places to surf.
Yes, Titan is a wonderful, wonderful moon. It is Saturn's largest moon. The only other moon in the solar system that's larger than it is Ganymede. And one of the reasons that Titan is so just fascinating and interesting is because it is the only known moon in the solar system that has a thick atmosphere and clouds. However, unlike on Earth, where we have the lovely water that rains down upon us, on Titan it rains a bunch of hydrocarbons. It's mostly nitrogen. I think 95% of the atmosphere is nitrogen, and about is methane in the planet. So this is sort of where the new research, or at least the new revelation, comes in. We have an overall picture kind of how the seasons work on Titan, and we find that the temperature variations on Earth, so between like the pole and where the equator is, can vary by 200 degrees Fahrenheit to about 100 degrees Celsius. On Titan, the changes are actually a lot smaller. So seasons on Titan last about 7 years because Saturn has about a 30-year orbit, 29-year orbit around the Sun. And it is when Cassini arrived there in 4, it got there around midsummer, towards the end of summer, I believe, and it was just about negative 290 degrees Fahrenheit, which is roughly negative 178 Celsius.
Nice balmy summer.
Yeah, so great times there. And the temperature change that we saw, I think the hottest, the warmest that it got up to was like, I don't know, just negative a couple of degrees, less than that. And interestingly, when you look at the poles and you look at the equator, the temperature variation, I think the greatest that we saw was just 6 degrees, only 6 degrees Fahrenheit temperature variation, 3.5 degrees Celsius variation. So it's super uniform, unlike Earth, where we have freezing temperatures and really hot temperatures and all sorts of craziness like that. And it's so cold that there's tons of frozen methane lakes. We have images from Cassini and Huygens and all that stuff. They estimate that there are certain lakes that are roughly the same size as the Great Lakes in the United States. I could just go on and on because methane is a lot less dense, about half as dense as water. So swimming through it, because there's so much less gravity, you might be able to jump out like a dolphin because the atmosphere there is so thick. It's about twice as thick as on Earth, maybe, I think. That's correct.
Yeah, you could wear wings and you could fly around on Titan.
Yeah. So anyway, the new paper came out and was just looking at the temperature variations over the course of the seasons on Titan. And just because it's so cold there and it's so completely different foreign to what we find on Earth, it's just really interesting.
Michelle, any hope of us getting a sailboat on Titan?
Oh, I wish, yeah. So, I mean, we proposed the Titan Mars Explorer a couple of years ago. That was Dr. Ellen Stofan, who was the PI for that. She's currently the chief scientist at NASA. She's a really incredible person. And this is one of these things where, you know, if I were queen of the universe and I got to fund whatever I wanted, I would have totally picked the Titan Mars Explorer. So that was actually going to, not so much sail, but it was actually going to put a little small boat in the oceans of Titan. And I mean, Titan's atmosphere and the way it interacts with the oceans is a big deal because, of course, there's actually something out of balance in the atmosphere, acetylene. And on Earth, bacteria that actually use methane, that we find in methane ice at the bottom of the oceans, actually use this chemical, acetylene. So the fact that there's this imbalance of acetylene is just really intriguing. It's one of these things where we certainly cannot say it's definitely life, but it's something we want to investigate and follow up. And we need to understand how the oceans and soil of Titan interact with its atmosphere. And by the way, I noticed there was a comment there. We actually do think you could actually fly using fake wings on Titan because the surface gravity is so low. So even though the atmosphere is only about twice the density of the Earth's, there's very low surface density. We actually don't even need a parachute so much to land things on Titan. Things kind of feather fall down. There's really not very intense gravity. So you might actually be able to have a new sport of flying in the atmosphere of Titan.
Oh, that'd be amazing.
I think it was something like if you weighed 100 some odd pounds on Earth, you would weigh about 12 pounds on Titan. So just a huge difference there.
Yeah.
So Kimberly, let's talk about going back to Venus.
Yes. Luckily, so does NASA. And now we actually have the technology to not only go back to Venus, but put a rover on the surface and have it survive for more than 2 hours. The previous record of having a lander on the surface of Venus and have it survive, the record is just about 2 hours, and that was decades and decades ago by the Soviet Union. And we've never really been able to beat that record because of the really intense surface conditions on Venus. It has a surface pressure of 90 times Earth's atmosphere. The temperatures are twice your household oven. It's crazy. So as much as we love Venus, and as much as we love to learn more about Venus, it's really difficult to keep something on the surface and have it not implode upon itself or, you know, burn to pieces. But NASA's Glenn Research Center in Cleveland, Ohio has been developing the technology to do just that, and they believe that they have finally figured out ways to get solar panels to operate on the surface of Venus for about 50 days or so, and to protect the scientific instruments that they need. And so what they've come up with is a design for a rover that actually uses a wind sail made out of solar panels on the surface of Venus. Now, the solar panels themselves won't be able to collect a lot of energy on the surface of Venus. Only about 1% of the solar light that hits the top of the atmosphere actually makes it to the surface. So the solar panels would not be able to actually power a rover and have it move around. So they needed to come up with a different mechanism to actually get the rover to move around the surface. And that's where the super thick atmosphere of Venus actually comes in handy, unlike on Mars. So even though Venus has very slow winds of only about 2 miles an hour or so, it has an incredibly thick atmosphere that could actually push this rover around using a wind sail.
It's like
so I think that is incredibly exciting.
It's like the opposite of Mars, right? Like on Mars, the winds go really powerful, but the air pressure is so low.
But they're so thin
that there's not enough to blow Matt Damon off of a, cliffside and leave him stranded on Mars. But with Venus, you would feel, only a couple of kilometers per hour wind, but in fact, it's enough to get that thing moving around.
Also, his face would melt off.
Exactly.
His face would melt off. We pitched to Andy Weir. He's got to do The Venusian as his next book because that's even harder. Like, get off that place, Matt Damon. You survive there.
Yeah,
so potatoes.
Yeah, now that we are starting to develop the technology to actually keep something surviving on the surface of Venus for a considerable amount of time, I think most people at NASA are really excited and want to push for it, and they think they may be able to get something funded and launched by 2023. So less than 10 years. That'd be really awesome if we could. It'd be something like a Discovery-class mission with maybe 7-8 scientific instruments on it. Super light payload, the whole thing around the surface. But we've never really gotten to explore the stationary landers and probes and orbiters. And this is the next stage, which is roving around the surface. It's exciting.
Yeah, that'd be amazing. Perhaps something, some rover you could just drop off the edge of your floating cloud city on Venus would be great. Okay, let's see. Nicole, do you want to talk about the fast gamma ray burst that you were so excited to talk about last week?
I don't know, but want to talk about?
Talk about it.
We have to talk about it.
Have to talk about it.
Yes. So the very exciting story we talked about last week of a fast radio burst. These variable sources we see in radio. We don't know what they are. There was a paper published in Nature came out last week. Talked about it on Friday. They had lined it up with a galaxy, and they said they caught the afterglow of it, and so they knew what galaxy it was in, and therefore knew how far away it was, and could find all the missing baryons in the universe. Cool.
Finally, we know what the universe is made out of.
Even just the normal stuff in the universe, not even the weird stuff. But I was noticing some chatter on some people's Facebook threads, some astronomers that I know, who totally didn't believe it, and I discovered that just a couple days later, a couple of astronomers did a follow-up observation of the galaxy, which they put out through Astronomer's Telegram. This is a thing, you guys. I have something published in Astronomer's Telegram when I was like an undergrad.
Yep.
Yeah. I mean, it's like way before Twitter and everything instant. We had the Astronomer's Telegram to tell each other about variable events and stuff to look at. So they found that the radio source was brighter than it should have been, actually brighter than it had been in the original study, which doesn't make sense for the colliding, I think it was colliding neutron star model that they proposed. It doesn't make sense at all to have it brightening so much and have it be as bright as it was. And so what a lot of people have been saying about this is that they underestimated the rate at which a fast radio burst might happen to line up with a variable AGN, active galactic nucleus, which is a supermassive black hole that is variable in time. So they think they did go through a calculation saying what they think the accidental lineup of these things would be, and that it was nearly impossible. And it turns out a lot of people saying, well, these things are probably a lot more frequent than we realize, and so the chance coincidence of them being in the same place is pretty high, and that this is what you were actually seeing. You were actually seeing an AGN. I'll share a link in the chat. There's a good discussion of it on a National Geographic blog. So the original team is basically saying, yep, we're going to keep working on it. That's a valid point. So, you guys are seeing all this science happen on the main stage because it was such a big story and was such a big hit.
Yeah, you remember that time when we said there was an announcement that was as important as gravitational waves? Just check back on that one.
We'll check back on it. Yes, we'll see. But I think it's another good push for doing more of this time domain radio astronomy, being able to see the whole sky at a given time and be able to catalog these variable sources a lot better. This is definitely still a big question mark for radio astronomers.
It's just another chance to bang the Large Synoptic Survey Telescope gong again.
Or SKA.
Or SK. For example, a square kilometer array of telescopes, radio telescopes. Yes. But to have, these instruments out there scanning for a dynamic sky is going to bring a whole new just level of understanding of what actually happens in the sky. It's going to be great. So, come on, Large Synoptic Survey folks, get cracking. And SK. Well, I'm sorry, Nicole. I feel like the universe...
Well, of course you're saying sorry. Stop saying sorry.
I know, I'm Canadian.
It's not your fault.
The universe giveth and the universe now taketh away.
Taketh away. That is the nature of science.
More observations. But this is how science works, right? You're watching it happen in real time. So sometimes these have to get taken away. All right, Morgan, but let's talk about a super cool supersonic jet.
Yeah, so we often talk about NASA on this show in terms of what they're doing in space, but it's easy to forget that the first A in NASA is aeronautics, and NASA has been responsible for funding the development of many of the pioneering aviation technologies that make all of our lives better every time we get on an airplane. And the one that they're working on next is quiet supersonic jets. And we probably all remember the Concorde, which was supposed to fly across the ocean in just a couple of hours. And it didn't really work out. And one of the reasons it didn't work out is because you can't actually legally fly supersonic jets over populated areas because they're really, really loud. And that very much limited the routes that the Concorde could take, which made it slower than it otherwise would have to be, and not very financially feasible. And so what NASA has done here has awarded a grant to Lockheed Martin to develop a new concept for a new X-plane that would test theories in how to achieve supersonic flight without making these large crack when you break the sound barrier and then have this sonic boom as you pass overhead. And if they can make this work, this will sort of pave the way to a future in which we can travel across the country, the United States, in just a couple of hours rather than the 6 hours or so it takes today.
I should figure out where the mute button was. Okay, great. Yeah, it's either that or the Hyperloop, right?
Yeah, the Hyperloop's not going to be your best friend, though, if, say, you want to go to Australia from Los Angeles. Hyperloop's going to be, hopefully, a positive technology for commuting intermediate distances within land-based travel. But if we want to go transcontinental, airplanes are going to be our method of choice for much time to come. And the faster that we can make that happen, the better we can stimulate business across countries, the faster we can go on vacation, and just overall better the transportation system will work.
Yeah, so, I mean, Paul Gracie is saying in the chat that the Concorde did work for about 20 years in its intended route. I mean, it did go Paris, New York, London, New York, and it made that trip. What the problem wasn't necessarily that it was loud. I mean, these were all problems.
Well, but it's not an accident that both of those routes were over the ocean.
Sure, but it was just
they could not have flown this Los
expensive.
Angeles to New York because they never would have been able to go supersonic for large periods of time.
Yeah, but it was just so expensive. You know, a ticket on the Concorde was whatever, $10,000, $25,000. Like, it was all the monies. right? And
it was absolutely expensive, and I think this is only going to solve one part of the problem. But there are other efforts underway to solve other parts. We now have aircraft that are made of much lighter materials like carbon fiber. Aircraft like the Boeing 787 or the Airbus A350 are made with much lighter materials that are more fuel efficient, and will allow us to make these journeys with much less fuel.
Yeah, as Richard Strassel is noting, just go for the commercial suborbital flight. So why do this halfway, right? Like, just get on your airplane, go suborbital, and then just reappear back through the atmosphere at some other part of the world, and nobody has to hear your sonic boom.
Well, one of the knocks against the Concorde, deserved or not, was always that it wasn't very safe. And it's difficult to imagine suborbital space travel ever even reaching the safety level of the Concorde, perceived or not, much less this basically flawless safety record of air travel.
Yeah, I mean, unfortunately we saw that re-entering the Earth's atmosphere is a very dangerous, high-energy event that has all kinds of risks, and it's what took out Columbia, and so lots and lots. I mean, I think a lot of people are really excited about that. Like, wouldn't it be so cool if I could get anywhere around the world in 5 hours, 4 hours, 90 minutes? It would be terrifying. So. I think it's okay. I'm all right with the slower routes, personally.
I'm not.
You want to go super fast? You hate flight. Get in the Hyperloop then, and away you go.
I took a 17-hour flight to South Africa once, and I wanted to tear my hair out. And I had an allergy attack on the plane, and the heating and cooling was bad, and everything was horrible. I would have much rather, blown my ears out with a sonic boom.
Richard Drum is noting that the Concorde would fly from London at 9 a.m. and arrive in New York City at 8 a.m. Which you gotta like the math there. A little bit of time travel going on. All right, Carolyn, let's talk about searching for life here in the ice.
Okay, so we were talking about NASA funding all kinds of cool stuff. Another cool press release came out. There's a NASA-funded project that will be built at Louisiana State University with a consortium of about 11 other universities and institutions, and it's called SPINDLE, which stands for Subglacial Polar Ice Navigation, Descent, and Lake Exploration. And essentially what it's going to do is go beneath these giant, deep glaciers that we have in Antarctica and look for life. This is a cryobot that's going down there. It'll have a little kind of a hovering vehicle, a reconnaissance vehicle called the I have to read this, Hovering Autonomous Underwater Vehicle, the HAV, and that will be what's searching for life, and it will collect samples. And so they'll start this out by trying to answer figure out the questions they're going to answer with it before they build it, which is a good thing. I mean, then after that, the team will build this instrument, and they will do their tests in the field, and then basically head down to the Antarctic in the next few years to do this. So the thing that I thought was a really cool thing about this is that you are doing this search for life on Earth in places that we think are inhospitable, but for the things that live down there, this is great. It's like you're visiting their house. Well, there have got to be places elsewhere in the solar system that also have that same attitude, and if we can do it here on Earth, then maybe we can build these things to go to Europa and Enceladus and Ganymede and places like that to do the same work.
Yeah, I mean, there's so many environments in the solar system that we're now turning up have this liquid water, and you're gonna have this edge where there's ice and where there's liquid water, and creatures that could very well exist in these kinds of habitats as long as there's a source of energy, and that's super exciting stuff. Louisiana State, not known for its ice, but
no, but I guess they're known for drilling.
Jolene, you get the last word. Let's talk about ESA's plans to build an international village on the moon.
Yes. So we've been talking a lot, it seems to be the theme of the Hangouts, at least the last couple of weeks, in part, NASA's plans to go to Mars. They want to get men and women manned missions there by the 2030s, which is no easy task. Just making rockets that can get to Mars takes years in and of itself. Then we need ways to keep the people healthy, medicine, then we'd be able to probably 3D print everything that they'll need, because you can't just bring all this material with you. The craft would weigh so much we would never get off the planet. So something that seems a lot more practical is starting small and getting to the moon. We haven't been back in, 40 years now? So maybe we should, try heading there first, establishing colonies, and ultimately that would make getting to Mars and other places a heck of a lot easier and a heck of a lot cheaper. Estimates say that by using the moon as sort of a base for launching to other interplanetary missions, we could save about $10 billion in trying to get to Mars, just because gravity is so low there and all sorts of stuff. Just makes travel a lot easier. To that end, the European Space Agency, they are not looking towards, let's get to Mars, woo, go there right now. They're focusing on the moon. So the new director, Jan Warner, hopefully I didn't slaughter the name, gave a talk at an international summit in December about the plans that the ESA has in relation to actually establishing colonies on the moon. And what's really super cool about this is there's an actual timeline, a real roadmap for how things are going to shape up, which is a lot more feasible, a lot more well planned out than sort of NASA's 2030 supposed Mars missions. And so basically they're just talking about getting there and not having people have stores and shops and things like that, malls on the moon. It's not about that. It's about having people living and working there so that we can make other interplanetary missions more feasible and more viable in the long term. So we're not really looking at packing everyone up and moving there, but from a scientific sort of space agency perspective, heading there and working from there as a way of making space exploration a lot more viable and cost efficient. The end.
Michelle, the moon or Mars? Where should humans go next?
Well, I think.
Are you even allowed to answer that question?
Oh well, one of the things I can say is I think it's sort of a misperception that NASA is just heading to Mars. The phrase we use is the journey to Mars, and that probably includes going back to the moon. So I mean, quite honestly, we do not have the technology ready yet to go to Mars, to actually make the trip, to actually be there for any length of time, and it makes so much more sense to do a return to the moon as part of the journey to Mars. So absolutely, I want my moon base. I know right now NASA is actually talking about partnering with the European Space Agency and others to have what they just call permanent human presence around the moon. The thing that NASA is really looking at right now is an orbiting space station. So a space station that would actually have a permanent human presence in orbit around the moon, and that might include missions back and forth that the European Space Agencies and others would be along for. So no, I mean, it's on the way to Mars, you get to the moon first. That's a big deal.
Yep. I think the moon first. In fact, the chat is mentioning pancakes, which is the analogy I made a couple of weeks ago, and they won't let it drop. So
I saw the pancake chatter. Yeah.
Yeah. The gist is, I'll do this one more time, which is that I have
guys so much.
I have for anyone who has no idea what this is, I have the fixings in my house to make pancakes. Anytime you want, if you want to make pancakes, I'll make you pancakes. I got all the stuff, and space exploration and colonization should be kind of the same, which is that we should have all of the technology, all of the ability, the knowledge about long-duration space flight, the kinds of thrusters, what it's like to live in low G, to be able to take on these additional goals in human space exploration bit by bit by bit, and to not kind of lay out this big long-term plan that's going to require multiple generations of presidents and Congress to kind of go, yes, we're still going to stick to your moon plan or your Mars plan, even though it might take 20 years to carry the whole thing out. Instead, just the overall capacity and capability of NASA's human space should just be increased to the point that any of these things are possible. Want to go to an asteroid? Sure. Want to bring an asteroid back to the moon? Done. Want to put some people on the moon? We got that. You want to hang out in space? No problem. Yeah, swim on Titan's going to be a little bit longer out there. But
I'm swimming on Titan.
Yeah.
In the next 10 years. It's going to happen, Fraser.
You're going to need a better wetsuit. Okay, well, so we should probably wrap this up. Thanks to everyone who watched us. Thanks, as always, to the WSH crew, which is the really the executive producers of this show, and especially thanks to Nancy Graziano for setting up our special guest and all our special guests. We really appreciate it. So before we go, I want to give people a chance to let us know where we can find out more. So Carolyn, where can people who want to read more of your stuff, where can they find you?
Oh, they can find me at thespacewriter.com and spaceabout.com and on Twitter at spacewriter.
Jolene.
At Futurism on Twitter, Futurism on Facebook, and Futurism.com is the website. Also Instagram. Now back on Google+. That was an issue for a while, but we're back, so here we are.
So Futurism all the time. Kimberly, where do people find out more?
People can follow me on Twitter at AstroKimCartier or my website, www.kimberlycartier.org.
Morgan.
Well, if you missed me at Astronomy on Tap last week, then you should check out my YouTube page to see my latest talk where I talk about a time and a place it wasn't crazy to think that the Earth was flat. Otherwise, you can follow me on Twitter at Morgan Rehnberg or visit
But it's crazy now, right?
.com. Absolutely, and I make that unequivocally clear.
Okay, good. Yeah, I mean, if you live in the Boulder area, you can see Morgan's planetarium shows and hang out with him at Astronomy on Tap. So you should do that. Nicole, where do people find out more?
I'll be walking my dog, so come find me walking. No, I am.
Don't invite them to do that.
No, that's true. Okay, I'm Noisy Astronomer. I go back to classes next week, so my availability will probably dip down a bit as I get another pile of grading to do. But yeah, I'm in New Hampshire, college professor now, which is crazy. Yeah, but I live on the internet as Noisy Astronomer.
So, of course, I'm FKN on Twitter. You can follow this YouTube channel, and I'm going to give you a little sneak, I'm going to whet your appetite. If you want to know about Planet 9, you're going to want to attend the April 8th episode of the Weekly Space Hangout, and that's all I'm going to say right now. You should join us then. Cool. Well, Michelle, thanks as always to join us this week. We really appreciate you joining us and bringing the NASA. Once again,
NASA. Yes, that's what we do.
people want to follow you on the Twitters.
Oh yeah, ML Thaller, or just look me on Facebook, or just go to NASA. Orbital Path. It's free on iTunes. It's National Public Radio. How good is that?
Fantastic. Well, thanks everyone for watching, and we'll see you all next week. Bye.
Bye. I'm still